Hi there, we're looking today at exercise 6A. It's in two parts, so I'll look at it properly. Now you may recall that we did binomial expansions in our earlier year 12 work. That's when you saw things like 1 plus 5x to the 8, or maybe 2 minus 3x to the 4. These are binomial expansions. The key here is that these are positive powers. We today are going to look at situations where we have a binomial expansion where it's not got a nice power. In fact, it's a pretty horrible power to the minus 0.5. So it's either a decimal, a fraction, or maybe just a negative number. This is negative and a decimal. And what we're trying to do is, now this f of x formula is actually the red curve. If you type this into a graphical calculator or into Desmos or something like this, you get this red curve, and it's not. Although that's the red curve, what we don't particularly like expressions like this to dodgy powers. We'd much rather is what we call a polynomial, which is like say, an x squared or an x cubed or x to the 4 or whatever. And what we try to do is find an approximating cubic or quartic or even quadratic curve which looks roughly like it. And this is the attempt. Now you might look at that blue line and think to yourself, that's nothing like the red line. But within certain parameters, maybe if we go up to there and up to there, you could say, well, that's not bad. It's not very good at this far end. As you're getting close to this far end, it's getting a bit weaker. But certainly between there and there, it's a very good approximation. And what we're looking for is to be able to find a polynomial curve which kind of matches the original red curve within certain boundaries. So let's see if we can show you that. Now this, if you remember, is what we did earlier in year 12. So when it says find the expansion of this, what we should remember is Pascal's triangle. And Pascal's triangle was great because it allowed me to write down what we call coefficients. And to the power of 5, you should recall it's 1, 5, 10, 10, 5, 1. And you can find that, for instance, this one here, you could find using 5, because it's to the power of 5, and C, 0, 1, 2, there, 5C2. And if you type that into a calculator, you'll get 10. So I'm going to use these now. It's 1 times the first one, which is a 1, to the power of 5, plus 5 times by the first one to the power of 4, but now I have to times by the 2x, plus 10 times 1 cubed times 2x squared. I put it in a bracket, of course, because I've got to remember to square both the 2 and the x. That's 10 times 1 squared. Those powers are going down at the same time as these are going up. Plus 5 times 1 to the 1 now times 2x to the 4. And my last term is simply 1 times by, well, the 1's have completely gone. It's just 2x to the 5. And I reckon this is, well, 1, that's 1. 5 times 2 is 10, so that's 10x. The 1 to the thing is 1, so I can ignore all of those. Now this I have to be careful with. This is where people lose marks. That's 2 squared. So 10 times 2 squared is 40x. And the x is also times by itself, so 40x squared. Now here I've got 2 cubed is 8, times by the 10 is 80. X cubed. I've got 2 to the 4, which I know is 16 times by 5 is 80. X to the 4. And the last one's 32x to the 5. So hopefully that's right. And yes, it is. Now the next one says, well, it's a very similar one, but now it's to the power of 4. You should remember the coefficient to these are 1, 4, 6, 4, 1. You might need to go back and revise all those coefficients if you can't remember Pascal's triangle. So it's 1 times the first thing to the power of 4. Now it's a minus, so I remember going plus, minus, plus, minus. So this one's a minus, and it's minus 4 times by the first thing to now to the power of 3 times by minus, times by x squared. Nearly made a mistake. Plus 6 times 3 squared times by x squared squared. Let's bring it all back now. 4 times 3 to the power of 1, it's nearly gone those, got one more term of those, x squared cubed, plus 1 times by 3's have gone, so it's just x squared to the 4. So what's this give me? 3 to the 4 is 81, This is 9 times, no, it's 27, sorry, times by 4 is 108, x squared. This is the 9 times by the 6 is 54, and now it's a plus 54. Now you can be a bit careful, x squared squared is x to the 4. If you remember, you times those powers together. The next one is minus 12x to the 6 plus x to the 8. There you go. So that's what we've done in the past. It's a reminder that to read the notes. These are the types that we're going to see today. Dodgy powers. Look at this, to the minus 1, to the half, to the minus 3. And it's these expressions which, to be honest, we don't like. We don't like them. And we try to write them in a new form. And this is the formula we use. It's a formula which looks horrible, but really it's just a number plus so many x, plus so many x squared, plus so many x cubed. And the so many bit we work out using the formula, this given to us in the table, in the formula book. This is when it's valid. This is what we call its validity. And basically, it's the two numbers between which those two curves are roughly the same, the curves that I showed you at the start. So here's an example. It says 1 plus x to the minus 1. So if I just do this, 1 plus x to the minus 1 is equal to, so what I do is I highlight what my n is. My n is minus 1. And it might sound strange, it's my x is actually x, because it says x here as well. So, okay, so my formula says 1 plus nx. That's 1 plus, what's n? It's minus 1 times by the x, because x is x in this example. Plus, and now it says n minus 1 over 2 factorial. So n is minus 1 again. n minus 1 therefore is 1 less than it, which is minus 2, divided by 2 factorial. And I've got to times by x squared. And it's x, because x is x. I'll see an example for you in a bit when that's not true. Next one is minus 1 for the n, minus 2 when I go down, minus, and you'll see these just go 1 down each time. Divided by 3 factorial. Now 3 factorial I know is 6. I know 2 factorial is 2, so it's not worth knowing these, but you can type these into your calculator. They come out all right. X cubed. And this then is equal to 1 minus x. Well, positive, that's basically positive 2 divided by 2, that's just 1 again. Plus an x squared. And that's minus times a minus, so that's a minus 6 divided by 6, so that's minus x cubed. So it's actually worked out very simple answer. And again, we just write its validity is such that mod x is less than 1, which basically means it's roughly accurate between 1 and minus 1. And that's what it says, and that's what it says. So another example, this is probably a better example. Notice, by the way, that in the examples I've given you so far, it's always been 1 plus. And that's because, oh, this one actually, it's 1 minus, but we think of that as the same thing. Critically, that first number's got to be a 1. If it's not, you have to make it a 1 somehow. We come to that in the next exercise. But for now, it says 1 plus x to the n, and our example is 1 minus 2x to the half. So again, just highlight in your mind, n in this example is a half. And my x actually isn't x at all, it's minus 2x. So when I come to write this down, I'm going to get 1, because that's what the formula says up here. And it says plus an x, so that's plus a half of, what's the x? It's really minus 2x. Plus n, which is a half. I've got to then take away n minus 1, times by n minus 1. I've got to take away 1, but I think it's minus a half when I do that. Divided by 2 factorial times by, it says x squared, but I need to know that it's minus 2x squared. And it says the first 4 terms, so I've got 1, 2, 3, I need one more term. And this is plus then, it's n, a half, n minus 1, minus a half, n minus 2, well that's actually minus 3 over 2, minus 1.5 if you prefer. Divided by 3 factorial, times by x cubed. It's not x cubed, it's minus 2x, all cubed. So let's write down what this is equal to. I get 1, that's easy enough. Half of 2 is 1, so that's minus x. And this is a half time. Now these are probably best done in your calculator. So I've got 5 times, interesting, I'm doing it as decimals, but you can type it in as fractions. And don't forget this actually means minus 2 squared. So I'm going to times that by 4 when I times minus 2 by minus 2. And I get minus a half. Now, x squared is still x squared. So, and then this one I'm going to type in 0.5 times minus 0.5 times the 3 over 2, 1.5, divided by 3 factorial, times by, and that is times by minus 2 cubed. I reckon that's minus 8. And I get minus a half when I do that. So it's minus a half x cubed because of the x cubed. And now, be careful on its validity. Its validity is actually now, well, it says x is minus 2x. And when I chuck it into this formula, I can ignore the minus because it's a modulus anyway. But it's basically mod 2x now is less than 1. It works as long as 2x is between 1 and minus 1. Or better, probably written that mod x, I'll move the 2 over and it's less than a half. Now this is what's going on. There's the minus a half. And there's the half. And what I'm really saying is between those 2 points, the blue line is a good approximation of the red line. And you know what it is. And I think that is the answer. So I'm quite pleased with that. Now this last example, we've got an expansion, which is this. Now it's not looking like an expansion, but really it's 1 plus a half x to the power of a half. Obviously a square root is a half. And it says write this up to the x squared term. So let's just do this. My n is a half. My x is really a half x. So this is 1 plus n, which was a half of a half x, plus n is a half, and minus 1 is minus a half, over 2 factorial times by what was my, it was a half x squared. There's my 3 terms up to x squared. So if I just tidy this up, I get 1 plus, I reckon, a quarter x. What do I get with this one? So I'm going to type into my calculator a half times by minus a half divided by 2 factorial times, now a half x squared here, I reckon that would be a quarter x squared. And I reckon that's minus a 32th, there is such a thing, of x squared. The validity of this, my x is really that, so chucking it into there, I now get a half x modded as less than 1, and I reckon if I move that 2 over, I reckon this is valid for mod x of less than 2, in between minus 2 and 2. Now, the last thing of this says, use your polynomial to find the approximation for the square root of 1.6. Now let's just go back. Or do I need to go on to the next line? Yeah, so I've got some space here. No, it said the square root of 1 plus 6, or 1.6. Now, my initial thing said the square root of 1 plus x over 2. So that's what I had, 1 plus x over 2. So really, you can look at those two things and say, well, if I'm going to use this thing, that 1 plus x over 2, they're saying to me, must be equal to 1.6. Effectively, it's saying, well, I know it says this, we need this. So we're going to replace the 1 plus x over 2 with 1.6. And the very first thing I'm going to do is move the 1 over. I get x over 2 equals, well, 0.6. And therefore, x is 1.2 when I move it over. And what that says to me is this is the formula we got before. This will be true for the square root of 1.6 as long as I write the x equal to 1.2. So it's 1 plus 1.2 divided by 4 minus 1.2 squared divided by 32. So if I quickly type that in, 1 plus 1.2 divided by 4 minus 1.2 squared divided by 32. And I get 1.255, so that's worked. So I'm quite pleased with that answer, and we got that as well. So look, that's the end of this. What you'll find is an exercise 6A that you've got questions for. There's a bunch of questions. I'm only saying to you to do certain ones of them because there's only certain ones at the moment you can do on the basis of this. So have a look at this, and then exercise 6A.2 will go through the harder versions of this. So just do a few, and hopefully that makes sense.